lecture 2 now. The lecture is basically going to start out with a short presentation, just outlining a few concepts and some terminology. A lot of you might know this already, but it's good to go over. And then after that, we will go into Visual Studio and start with our first topic in Python. Just also, if you have questions, please ask them in the chat. Don't unmute yourselves, and please leave your video turned off. So let's get started. So previously, what we've done is we have installed Visual Studio, we've installed Python, and we installed Jupyter. So that should all be working. And then we downloaded the course content. So the first thing that we can look at is Python environments. So this is where Condor fits into everything. So if you think of your computer overall as being this blue box, it will have some version of Python running on it. And this version of Python will have a bunch of packages.
Sorry, Mark. So I'm just showing the results of the poll.
Okay, no problem. You can pause.
So I don't know if you, I hope you see it, but so there is only one person who is not saying that they couldn't install.
Okay, so get back to us. We'll sort that out later. Just follow along with the lecture. And afterwards, just post the thing on Slack or Stack Overflow, and we will get everything working. So basically, your computer, most likely, your operating system most likely needs Python to run. And it needs a bunch of packages, and these packages have to be very specific versions. So what happens is if you use this version of Python and you updated something, it might cause problems with your operating system. So this is where Condor comes in, and it's got its own environment that runs Python. And this big orange box you can think of as being your base environment. This has a version of Python and it has some packages. Then when we make environments like we did with ITP 2020, this is now contained as a sub-environment within the Condor environment. And this is called a virtual environment, and it will have a version of Python and it will have packages that it needs. And you can have as many of these as you like, and none of these will interfere with your system's Python. So this is a nice clean environment to work in. Another advantage is if you keep this lightweight and it only has packages that you use, when you need someone else to use your code, you know exactly what versions of the packages you use. It's not because there's some other package installed in another environment that's giving you functionality that you don't know about. So this keeps everything in check, and it makes it much easier to share your code down the line. So some other things, luckily with Visual Studio Code, you don't need to work with the terminal very much, but the more you code, the more likely it will be that at some point in time you are going to start working in the terminal. So these are just some very basic shell commands. There are thousands of shell commands. This is enough to like get started. The first one, pwd, this lists the path to the working directory. So that'll be the current directory that the terminal is pointing to. The second is cd with some path. This changes the directory. So this is how you navigate in the terminal to different folders. mkdir will make a new directory in your current directory with whatever the name is that you give it. Something to note is that you will not go into that directory when you create it. You will then still need to cd into that directory. ls will list the contents of the current directory, just the file names. ll or ls-l, sometimes ll isn't configured on all terminals, will list the contents but with information. So how big are the files, what are their permissions, and more detailed information. cp is to copy. So cp takes two different paths. The first is the path to the file you'd like to copy, and the second is the path where you want to copy the file to. There is a similar command. I think if you're using PowerShell, ls-l might work. I'll have to look up on that. And then MV is copy will keep the original and make a new copy at the to path. MV moves the file, so it'll move it from where it is to a new path. This is much faster with large files because it doesn't actually copy anything. It just rechanges pointers on your hard drive. So as long as you're keeping the file on the same hard drive, this is instant. Copying will take a long time if the files are very big. So the next type of commands is, yes, dir would also be an option. Okay, so yeah, ls-l is the equivalent in PowerShell. That'll list the same contents with the information about the file. Okay, so the next thing we're going to get onto is Condor Commands. So Condor is a program that is running on your computer. So whenever you want to run a Condor command, you have to tell the terminal that Condor is the program you're running. There are a bunch of different commands you can run with Condor. These are just some of the common ones. The first is create. We've done this already. So this will create a new environment with the name. So -n means we're going to give it a name. This is the name of the environment. Then we specify Python equal to whatever version of Python we'd like to use. And then we can list a bunch of packages at the end if we'd like to. So we already did this in the last lecture. So we did Condor create -n ITP 2020 was our name. Python equals 3.7 is the same. We then installed JupyterLab. And this was just, these are just some other packages that you could install. So you can list as many packages as you want after this. Seaborn is for plotting statistical plots. Pandas is for like Excel and working in data frames. And NumPy is more advanced numerical operations, so vectors and matrix operations, things like that. Something else you can do is you can list all your environments. So once again, Condor is the name of the program. env is what operation we'd like to do, and list is the functionality of that operation. So this will give you a list of all your environments. Condor activate with an environment name will make this environment the active environment. This is all, a lot of this is handled by Visual Studio. So you have to still create your environment, but the activating Visual Studio takes care of. To remove an environment, instead of creating, we have Condor remove the name of the environment with that environment name. And then this flag tells it to remove all the packages from the environment. And finally, if you'd like to install any packages, once you are in an environment, so first activate the environment that you want to work in, then you can type Condor install and the package names. So in this example, we could have Condor install JupyterLab, Seaborn, Pandas, NumPy. This would install these packages into that environment. Python, there are very few commands actually with Python, which is nice and easy. So the first is if you just type Python into the terminal, this will launch Python in interactive mode. And when Python is in interactive mode, let's actually do that. So if we look at the terminal and I type Python, when you are in Python mode, the start of every line will always be these three greater than symbols. So if these symbols are there, you are no longer in the shell, you are now in the Python interactive mode. To get out of this, you type exit with parentheses and push enter, and we are now back in the shell. So something else is a lot of people have a different shell to mine. So I'm just going to make a new bash shell. So this would be more what most people would be seeing. So the name of your computer, followed by what folder we're in, followed by the username, and then a $sign at the end. So at the same thing, if we type Python, we now have the start being these greater symbols. So we're in Python now. We can type print hello world, and that'll print hello world, and then we can exit, and we are back in the regular shell now. That message, this Python interpreter is in Condor with environment, something like that. Okay, so if you're getting something like that, just type Condor activate. And that should activate your Condor environment. And hopefully you won't get that warning anymore. If you still do, just post something in the Stack Overflow and we'll help you get that working. So that was the first Python, running Python into active mode. This isn't the best way of running Python always because it's quite hard to write code in this way. If you try using it for a while, you'll see what I mean. The next way is you have created a file with all your Python commands in it. So you give this file some name, it has a .py extension, and this will go through this file and execute each line in the file line by line using the Python interpreter. And then finally, you can run Jupyter Notebook. So this, you need to install the Jupyter package to do this. And once it's installed, if you type Jupyter Notebook, it'll open up your browser and with the Jupyter interface. So we're not using this. We are using VS Code's built-in Jupyter interpreter. So you don't need to do this. But if you're working on another computer, maybe that doesn't have VS Code, this is how you would open Jupyter Notebook. And let's just do that quickly so everyone can see. So I have got Jupyter installed. So if I type Jupyter Notebook and I don't have Jupyter installed. Let me go Condor deactivate. So Condor deactivate will deactivate the current environment. And then Condor activate ITP 2020 will activate that environment. And now if I type Jupyter Notebook, this starts up Jupyter and it will start running from the directory that it was launched. So this is the same contents I have on the side here, and you can open a notebook in this and run it in the same way. So the way you can do something like that, let me just close this, is what you can do to check which Python you're using is you can type which Python and look at this path that comes out. So you see I'm in this ITP 2020 environment. The other thing you can do is you can check your Python interpreter at the bottom. And if you hold over there, it gives you the link, gives you the active one. Otherwise, if you click on this, in this bar at the top, it tells you which is your active environment. Okay, so those are some Python commands. So those are basically a brief introduction to commands. It's enough to get you started if you want to start doing that. And as time goes on, you will get better at navigating the terminal. Something that is worth noting is that you don't need a mouse at all to use your computer. You can do everything from the terminal. So anything you can click on the computer, you can generally do from the terminal. Okay, so I'll get someone, I'll hopefully be able to help you with that while I'm talking. I'm not sure what that error could mean, but I also don't want to run out of time. So I'm just going to keep going. And those sorts of errors we're going to have to fix afterwards. Okay, so the next thing we're going to look at is just the components of a computer. So these are just good things to know in general. So a motherboard, which is shown in this picture, is basically the part of the computer that links everything together. It has different slots that different things plug into. This slot over here is for your CPU, which we'll discuss later. That's a heatsink that helps cool it. This is your CMOS battery that helps this needs power constantly, so that battery provides power. This is called a PCI slot. And a graphics card would get plugged in here. Your RAM would get plugged into these slots. So basically, this links everything together on the computer. It provides power for everything, and it keeps everything interconnected that needs to be. So the next component is the CPU, which is the central processing unit. This is a little chip that gets plugged into the motherboard. This is the underside of a CPU. And it has lots of little pins on it. These pins all go into specific slots. If you bend one of these pins, this will no longer work. So you have to be very careful when you're doing things with the CPU. What the CPU does is it does all of your computing. It does this one thing at a time generally, and it is very good at doing one command at a time. And yeah, so that's basically does all the mathematical operations, things like that. A lot of that's all done on your CPU. The next component is your RAM. So RAM stands for random access memory. The unit of measurement for these is generally going to be megabytes or gigabytes. This is short-term memory. What that means is that when your computer is turned off, anything that's stored in the RAM is lost. But the advantage to this is that it's very fast to read and write from, and you can have differing amounts. So from 512 megabytes to 128 gigabytes, depending on the motherboard. And if you start working in high performance computing, you can actually get higher amounts than this. This is just on a standard motherboard that you would buy for your home computer that you can get these ranges. The next thing that we're going to look at is the hard disk drive. So this is another form of storage like RAM. This is also measured in gigabytes, but it is generally much larger than RAM. So we can get terabytes or even petabytes worth of data on a hard drive. This is persistent memory. It is stored even when the power to your computer is turned off. The problem with hard drives is that they are much slower than RAM. So they can store more things, but they're much slower. But this is becoming less and less of an issue. Hard drives are becoming faster and faster. Another thing that you're going to generally do with programming is you will load information from the hard drive into RAM. So that's a general workflow. A file will get opened from the hard drive. That process moves the information into your random access memory. When your files are too big to fit into your RAM, then what happens is it actually breaks up the file into small sections, and it loads the file sections at a time, and you process each section at a time. So we'll get to that in about the 6th lecture, how these sorts of operations work. And the final component, this component isn't actually necessary. A lot of the time this is built in nowadays to the CPU, but this is called the GPU, which is a graphical processing unit. These have actually multiple measurements. So the first is gigahertz. This is how fast it can do operations. Then it has gigabytes. This is how much RAM it has. And finally, how many cores it has. So these all represent different units for the graphics card. The RAM, graphics cards have got their own RAM to store information on. And this will generally be in gigabytes. So between 1 and 24 gigabytes, depending on how expensive your graphics card is. And what graphics cards do is they do lots of operations at the same time in parallel. So a good example of this is if you had 512 different numbers and you wanted to multiply all of them by 2, the CPU would have to do 512 different operations to cover all 512 numbers. The graphics card can handle all 512 at the same time. So in one clock cycle, it will be able to do large numbers of multiplications. These get very expensive for high-end models. And if you get into machine learning, graphics cards are very important nowadays because a lot of their models are built using these to make them faster. Okay, so the last thing we're going to look at is just file sizes. So this is quite detailed, and it's not something you have to be too worried about at this stage, but it is something you should be aware of. So the way this works is that computers use 2 different states to store information. So on and off, and one unit of on and off is called a bit. And any type of data on a computer is made up of groups of bits. So a single bit represents 0 or 1, and a byte is made up of 8 bits. A kilobyte is a unit of measurement, is made up of 1,024 bytes, and the megabyte is 1,024 kilobytes, and so on. So it gets bigger. So for an example, if we wanted to store characters, so any type of character on a computer, generally they are stored as 8 bits of information. So 8 zeros and ones grouped together make up a character. Though with all of the emojis coming out now, they ran out of space in 8 bits. So now there are 16 bits worth of information when storing characters. So if we have got 8 bits, each representing 0 or 1, it means that there are 256 possible different numbers that can come out. So we can have 256 characters represented by those numbers. On the other hand, if we use 16 different bits to represent our characters, we can have 65,536 different characters represented using these numbers. So this process is actually the same with numbers. If we use 16 bits to represent only positive numbers, integers, this is called unsigned, so it's only positive. We can represent numbers from 0 to 2 to the power of 16 minus 1. So that means that in 16 bits, we can store the numbers 0 through 65,535. So if that is the largest number your program needs to think about, you can use a 16-bit integer. If your numbers need to go bigger, you would then use 32-bit integers and things like that. So a bunch of different variable types are just different groups of bits that will represent different types of information. So a regular integer will represent both positive and negative integers. And instead of being 0 through 65,000 in this case, it would be negative 2 to the 16 minus 1 over 2 to positive 2 to the 16 minus 1 over 2. So it would be 30-something thousand to 30-something thousand. uint is what we described over here, so unsigned integers. Floats are floating point values, so these are values with decimal places. Chars are either 8 or 16-bit characters, and booleans are either true or false values. The slides are on OneDrive, so if you go there, I have uploaded them before the start. And finally, something is just think about as binary. So this is how computers count, so zeros and ones, and how numbers are represented. So one character, as we previously mentioned, in this case would be 8 bits. So ASCII is a coding standard for 8-bit characters, and UTF-8 is also a different coding standard. I have the link at the bottom here for the ASCII character set. And if we look at this, the first numbers represent different things that aren't actually characters. They are end of lines and cancel operations and things like that. And then once we get a bit further on, you get the single quote character is represented by the number 39. The open parenthesis is represented by the number 40. So each number that's represented in by our bits is actually mapping to a different character. This is then the binary representation of this 41, and that maps to a parenthesis. So further on, we get decimal 48 maps to the character 0. And if we go further, 65 maps to uppercase A. If we look a bit further on, 97 maps to lowercase a, and so on. So the way that binary works is that each position, so each of these will represent 0 or 1. And if this is set to 1, it represents 64 in decimal units, and you then just sum up all these values to get your decimal value. So binary starts with 1, 2, 4, 8, 16, 32, 64, 128. So it's going up in powers of 2. And if we were counting in binary, so yeah, we've got 4 bits that we are representing. If all the bits are set to 0, this represents the decimal number 0. If the rightmost bit is set to 1, this represents the number 1. If we set this number to 1 and everything else to 0, it means that this represents 2. So that's from this 2 over here. If we set both of these to 1, we sum them together. So this is setting 2 is on and 1 is on. So if we add them together, we get 3. And that's how binary works. You're not going to use that at all in this course, but later on, when you want to start doing more technical things, working with binary files, things like that, you need to learn how this works in depth. So these are just some examples that I pulled out from this ASCII table. So if we have the decimal number 58, that's its representation in binary, and that maps to the colon character. If we have 65, that's the binary representation of 65, and that maps to the uppercase A character. One thing that this is useful to know is that when you are sorting, it uses this decimal value to sort characters. And for that reason, uppercase characters have got a lower decimal value, so they will always be sorted first before lowercase values will be sorted. So something else to be aware of. When you're comparing which comes first, A or B, it looks which of these two numbers is smaller. Okay, so basically this is just a stop to think about moment, and we know that characters are made up of bytes. So if we wanted to work out how big would our file be if we had 1,000 characters in it, we can now work something like that out. So each character represents 8 bits or 1 byte. So if we have 1,000 characters, it will be 1,000 bytes, and that will come to roughly 1 kilobyte. So this isn't taking compression and advanced things like that into account. If you just save a text file with 1,000 characters in it, it will be about 1 kilobyte big. If you saved it with 1,024 characters in it, it would be exactly 1 kilobyte big. And finally, I'm going to stop on this slide for a little while. So I've made some, yes, spaces count. I don't know what the number for a space is actually. You can actually check these things in Python, which is quite interesting. So if you open the Python interactive shell and you use the ORD function, ORD tells you what the numeric value of a character is. So if we put a space in, space is decimal 32. Okay, so I'll wait on this slide. Basically what we're doing in this operation here is we are going to update our GitHub repo. So I've uploaded a new Git lecture 2 file. I haven't made big changes. I basically changed the date and I updated these instructions in that file. So if you can't get this working and you have the file, it's not the end of the world. I'll explain quickly what this is doing. There will be more information on Git and GitHub at the start of the next lecture. So for now, don't worry too much about the technical details about what's going on here. So what this process is doing is we are going to be making a new branch that contains the changes. Yes, I have been using Python 2.7, but these things I'm doing now won't make a difference if it's Python 2 or 3. So the first thing you want to do is open the command palette. This is done using Control-Shift-and-P on a Windows computer and Command-Shift-and-P on a Mac. Alternatively, you can click this cog in the left corner and choose the command palette. Alternatively, you can go View at the top of your screen and Command palette on a Mac. This one should be the same on both Windows and Mac, so that's probably the better one to use. Once we've done that, we are going to enter Git Checkout 2. Just be aware this greater than symbol is necessary, so don't delete that. It should be there by default. You don't need to put it in twice. And Git Checkout 2 is basically going to be, what this does is we're going to check out a branch. So a version of files. And the 2 means that we're checking it out to some different branch. So the next step that we're going to do is select create a new branch from. So we're checking out a new branch and we are going to be using another branch as the base. If that command doesn't exist in your Visual Studio, it means you most likely haven't installed Git, would be my guess. If you get, yeah, that would be my guess. If you have cloned the repo already, don't worry too much about this. Just post something in the Stack Overflow and I'll get back to you on how to fix all those problems. So creating a new branch from is creating a new branch using another branch. The name of our branch is going to be lecture 2. And we are going to clone from origin master. What this means is that you generally will have two master branches, one on your local computer and one on GitHub. So origin means it's the master branch on GitHub. If it just says master, like over here, this is the master branch on my local computer. So we want to clone from the one online. Okay, so there's a solution to the Git. If you need to clone the repo, I mean, I can't cover that again now. So I covered that in the last lecture. And the way you do that is using the git clone command with the URL that's in the course outline. If you look at the dates on lecture 2's IPY and B, the lecture 2 Jupyter notebook, it should be updated to today's date. The other thing that you'll know if it worked is if you look in the bottom corner here, it should say lecture 2 instead of master. So if I follow these steps, so if I go git checkout 2, create a new branch from lecture 02 and origin master, you'll see now that it has changed this to lecture 2. And hopefully if you open lecture 2's notebook, it should be updated with today's date. If not, we will have to do this in a different way. Has that worked for anyone? Okay, sorry, here you go. Okay, good to know. If it's giving you an error that lecture 2 exists, just call it new lecture 2 or something like that. Just give it a different name. Okay, if yours is still July 2019, it means that it hasn't updated to the newest version. Okay, so if that did happen to you and yours is still 2019, this doesn't work as well as I thought it would. What we'd have to do is add an extra step where basically the extra step would be opening your command palette and just typing git pull, and that will download the changes from online. So you need to add an extra step at the end of this, open the command palette and use git pull to pull the changes to the directory. One of the big issues that with working with Git is normally when you're working with Git, you'll be a collaborator. So you'll be able to push your changes upstream, but it's not possible with having this many people working on the same repository to do that. So this causes a broken cycle. So you can pull my changes, but you can't push your changes upstream. And that is why this creates a lot of problems throughout this. So okay, so if yours is still saying July 2019, open your command palette again and use the git pull command. That should update it. So what pull does is pulls changes from another repository. So it will pull the changes from GitHub to your local system. Oh, okay. This is definitely not working as well as I thought it would. Okay, so we're going to have to try something else. what we're going to do is we're just going to go git checkout to and select master. Yeah, sorry, it's difficult testing these things on my computer because I don't have two versions of everything to see if I can pull and push from. So just change the branch to master. Another way you can do that is just clicking in the bottom corner here and choosing the master branch. And then once you're on the master branch, click this little circle over here on the side, and that should update the repo. Hope. Okay, so the issue with this is that it's not linking lecture 2 to the origin master, which I thought it would. So I'll look into this and I'll get back to you. So for now, let's just stay on the master branch. That's fine. We will fix these issues as they come up. So this happens in the background. You wouldn't really see anything. One thing that you can do is if you go into the terminal and you type git status, it will tell you which branch you're on, and it'll also tell you what the status of your branch is. So hopefully yours would say your branch is up to date with the origin master. The thing I was worrying about this is that if you have made some changes to these files, you might get something called merge conflicts. Anyway, I'm going to get going with this. So hopefully I'll try think of an easy way of getting these things to work for the future. If they don't, once again, it's not the end of the world. You just might lose any information you put into your notebook that's different from mine. Another rudimentary way of getting around this is to have two clones of the repo in two different directories. One would be yours that you make changes to, and one would be the one that I make changes to. So that's something else that you can just keep in mind. So I'm going to minimize this. And okay, so this is just the Jupyter Notebook. Jupyter Notebook have got two types of information that you can add. The one is Markdown. So if you double click on this first cell, this is called Markdown. And it's just a way of telling text to have different formats. So adding a £sign to the start will make it a heading. Adding 2 will make it a slightly smaller heading. And pluses set them as bullet points and things like that. So pushing Shift Enter will run a cell. So that will cause the Markdown to then be formatted as Markdown. Another type of cell, we'd have to go a bit further down, are these with the arrow. So these are actually Python cells. So this is where you can type Python code. So something like print hello, and if you push Shift Enter, it will execute that cell. So let's get started. So basically, at this point in time, we haven't really got anything that we need to worry about. At the start of the slides, I will generally put if there are assignments going out or anything like that, I'll have it at the top here. And so far, what we've covered is setting up your computer. So getting Python to run, getting VS Code to work. We've also set up a Condor environment for this class. We have run Python in interactive mode in a Jupyter Notebook like this. And hopefully we have cloned our Git repository from GitHub. So everyone should be on this stage, hopefully. And today we are just going to be looking at some basic Python. So the first thing we're going to look at is the different data types you can represent in Python. And we are just going to be looking at simple data types. Later on, we'll look at more complicated data types. Something else we're going to look at is logical operations. So Boolean, true-false operations. We will then look at how you can store data types in variables, and we'll look at some naming conventions for variables. And finally, we will look at some expressions and simple statements, and then some, I forgot to update this. This might not be there, but I think I do have some stuff on mutability. We'll see when we get to the end. So these are just the instructions I had in that slide. This you can actually ignore because this does not work as well as I thought it would. So I will come up with another way of getting the changes from the online GitHub branch. So to start out with, let's talk about data types. So primitive data types are the most base data types that you can represent in Python. And there are three different types that they can be. The first are numbers, and numbers consist of two different subtypes. So the first are integers, which are whole numbers. So 3 would be an example of an integer, and these are negative and positive whole numbers, including 0. The other type are floating point numbers. So these are numbers that have decimal places, so 3.4 or 5.0. So the way you can tell the difference, integers will never have a decimal place, and floating point values will always have a decimal place, even if it is a round number. So it would be negative 3.0 if it was a float, and it would be negative 3 if it was an integer. The next type are logical types, so booleans. These can be one of two values, so either the value is true or it is false, and in Python they are represented using an uppercase T with saying true and uppercase F for false. So those are, you represent those two types. And the last type we're going to look at today are text sequences. So what this is it's called a string, and it's a sequence of characters. Some other programming languages have a type for a single character. Python does not have anything like that. So the only way of representing text is as strings, and this is a sequence of characters together. And the way you represent them in Python is with quotation marks and whatever you want the string to be in the middle. So in this case, bananas is the string, and Python knows that it's a string because of those two quotation marks. So some other types that we're going to discuss in a few lectures' time are sequential types, so lists, tuples, and ranges. So text is actually a sequential type because it is a sequence of characters, so it's a very specific sequential type. Lists, on the other hand, are more generic. You can have a sequence of anything you would like. And then tuples are that's quite advanced, a little bit more advanced, so we'll get to that later. Another type of sequential, almost sequential, is a set. So sets are groups, and they can only have a single copy of each value. Dictionaries are key value pairs. Functions and classes, these are also more advanced types. So we will speak about those in the coming lectures. Just know that they exist for now. So something that's very useful is you can leave comments in your code. So using the pound symbol indicates to Python that anything following it should be ignored. So in this case, we have print with the number 3, and everything following this pound sign is ignored. If you click the plus over here, you can add a new cell underneath this. And then we can just put this code into that cell. So you'll see that Visual Studio colors things. So comments are always colored gray so that you know what's commented out. So in this case, it'll run print 3, and it'll then ignore everything after that pound sign. So this prints 3. If we put the pound sign at the start of the line, it will just ignore the entire line. That won't do anything if we execute it. So Python's got a bunch of functions, which we'll speak about more later on, but for now we're working with a few simple functions. So the one is print. So this function will print to the output whatever is in the parentheses. Another function that's quite easy to work with is type. And what type does is type tells you what type of variable or primitive you are dealing with within those parentheses. So in this case, if we try run this cell, it will output that the class of this number 3 is an integer, and then this comma over here is just separating things that we want the print statement to print. So that's just the nuance of using print statements. You can have A, B, C. This will print each of these with a space separating them. So just be aware of that while we're doing this. So if we take this whole block of code here and then go through them. In the first case, we're printing type of 3. So that doesn't have a decimal place, so it is an integer. In this case, we are printing the type of 2.5. So because it has a decimal value, it'll be represented as a float. The next, we have a string, and this will be represented as a string. True will be a bool. But then if we have a number 3 in quotation marks, this is actually treated as a string because of the quotation marks. So the 3 character is different from the 3 value, which makes sense and is useful to have, because if you wanted to print 3 in text, it's different from having the numerical 3. So if we run this block by either clicking this plus or pressing Shift Enter, it will then print out the types for all of these different values we had represented here. So that's just following along with all of those things. So these are the building blocks of any program you're going to be making. So it will generally consist of a mixture of different types depending on what type of program you're building. But just on their own, these primitives can't do very much. So there are a bunch of different operations that you can apply. With regards to single or double quotes, both are fine. The reason that you have both is that if you need to print something like quotation marks in the string that you're printing, you would use double as the outer, single as the inner, and then this would print the quotation marks. The rule that generally you should follow is to always use double quotes and not single quotes. I just have lots of bad practices, so this gets fixed for me by a program called Black. But yeah, use double, don't use single, though they are perfectly interchangeable and nothing will break whether you use one or the other. So every single one of these primitive data types that we've spoken about have got a bunch of operations that can be applied to them. And there are lots of these operations, and we're just going to look at this stage at some of the most basics. So in terms of mathematical operations, these would be for numeric types, so either floats or integers. The first type, so parentheses are just used for grouping your functions, and the Python follows PEMDAS, so anything in parentheses will always be calculated first, and it's always good to be make your code as easy to read as possible, so bracketing is highly recommended. The next operation is exponentials. So if you wanted to put x to the power n, you would use 2 multiplication symbols. Something to be aware of, though, is that a lot of mistakes people make is to use the caret for this purpose. So if I said 2 to the 5 and I run that, I don't actually get an error, but this is not an exponential. This is doing something called bit shifting, and it's not something we're going to be covering in this course. So if you ever want to use exponentials, do the double asterisk or else use the math.pow function, I believe. All right, so the next operation we can do is multiplication. So that's just a single asterisk. So in this case, 5 times 3. The next is division, and that's represented by a /. So something to be aware of is that whenever you use a single /, even if the one number goes cleanly into the other number, this will always return a float, even if you're working with integers. On the other hand, if you want to always get an integer coming out, you can do what's called a floor or an integer division, which is 2 /, and this will always round down. So in the case of 7 floor divided by 3, there's no decimal place. This just rounds down to 2. And this will always return an integer. So this becomes in handy later on when we're starting to work with lists and things like that, because your index always has to be an integer. Okay, Then we have addition, which is just a plus, subtraction, which is a minus, and finally modulus. And modulus will return the remainder of a division. So if you divide something by 2, if there's a remainder, it will return 1. If there's no remainder, it will return 0. So that's a fairly common application of modulus, is to see if numbers are even or odd, and that's how you would do that. So this block over here basically just applies all of these operations, and the first value that gets printed is just a string representing what the operation is, and then the second part of the print statement is actually performing that operation and then returning the result of the operation. So if we run this block, we'll see that in the first block we had 1 plus 2 equals being the string. So that's the string that's represented at the start here. And then we did the operation 1 plus 2, and that equals 3, which is being shown over there. So 2 minus 1 gives us 1. 2 times 5 gives us 10. And you'll notice with the multiplication, these were both integers, so the result is an integer. If on the other hand, I did 2.0 multiplied by 5, you'll see that this result is a float now, so it's got a decimal value. And then the same with the division. If we divide two integers, even if they go in cleanly, you will always get a float coming out. And if we do a floor division, you will always get an integer coming out. Then 2 to the power of 3 is equal to 8, and 16 mod 3 is 1, because 3 goes into 16 5 times, and then there's the remainder of 1. So 3 times 5 is 15, and there's 1 left over. And finally, bracketing, the rules follow PEMDAS. So 1 plus 3 will first be calculated, 4 plus 5 will then be calculated, and the results will be multiplied together. Versus this case where 3 will be multiplied by 4, and then the results of that will have 1 and 5 added to it. So those are the basic types, the operations you'll be doing with numeric types. There are some more, but that's enough to get by for now. Another type we had was strings, and strings have got their own operators that can be applied to them. So the first operator is addition, and this is if you use a plus in between two strings, it will then add the two strings together. So if we had BAN plus A and A, that will give us banana as the combined string. And something else we can do is multiplication. So we can take BA and multiply it by 5, and this will then repeat BA 5 times. Another operation that we can do, which we're going to definitely be covering later on, is called slicing. So because this string is made up of a bunch of characters, what we can do is, sorry, this should show those. What we can do is take the banana and go from the first character up until the second character, but not including. So 0 and 1, and that will return BA. So slicing has 3 values: the start, the end, and how much to go up by every time. That's going to get covered in about 2 or 3 lectures time. So for now, the only ones we have to look at are the concatenation, which is the addition operator, and the repeating, which is the multiplication of strings. So if we run these two together, you will see this is the operation we're trying to perform. So we're trying to take BAN and add A and A to it, and then we are doing that operation as the second part of our print statement. In the same way, we are taking BA and multiplying by 5, like printing what we're trying to do, and then we're printing the results of that. So these are the results. If we have a plus, it'll add the two together. If we have a multiplication, it will repeat that many times. So if we had to try and take a string and do a subtraction and run that, you're going to get an error. So don't be worried when you see these. It'll always be, when you're working in Jupyter, it'll always give you this red line and some red text telling you that something's gone wrong. In this case, we're getting a type error. So what a type error is it's saying that the string type doesn't know how to process a minus sign, because this makes no sense to Python. It doesn't know how to interpret what we're trying to say here. And that's exactly what this is telling us in the error. It's saying that there's an unsupported operand, so the minus, for a string type and a string type. So this string refers to what's to the left of the operator, and this string refers to what's to the right of the operator. So you're going to get a lot of these when you're writing Python code. It's good to take your time and read them, because over time you'll learn what they mean, and it'll be very quick for you to say, oh, I got a type error. It means that I had some operator that wasn't compatible. And then if you update that, it'll work with the correct operator. So the next thing we're going to look at is that basically Python consists of objects, and everything in Python is an object. So this is just the nuance of the Python language, and it's something to be aware of. You will hear people speak about object-oriented programming and creating classes. You do not need to use those to work in Python. Python lets you get by without having to write all these complicated objects and things. Just know that everything is an object. And what an object is each type of thing, an object in Python, has its own attributes, and it has its own methods that can be applied to it. And we will look at these in a bit more detail in this block of code. What methods are is just operations that can be applied to the object. So in this case over here, we have .upper. So banana is a string, and it has a method called upper, and we access that method by adding a period at the end of the banana, and we call that method by adding parentheses to the end of that. So access using the dot and make it run using the bracket. So before I get into any of that, let's just break down what this means. So banana is a string. So that's whatever the string is. When we push dot, we'll get a box of all the methods that can be done for a string. So there are a few different types of methods. Anything that just starts with a character is something we can use. If you come later on, you will see these with double underscores. These are called dunder methods. You should just ignore these. These are things that Python needs in the background, and they aren't things that you would want to be working with. So in our case with the string, any of these things we can run, and there are lots of examples of different methods we can use. So the one I was using was upper. So if we start typing, you'll see the upper method. And if we just run this as it is now, this is telling us that upper is a function, and it is a function that has applied to a string, and the signature is upper. So this isn't actually doing anything. It's just returning the function that's going to get run. If we actually want to run this, we need to put parentheses at the end. So this tells Python that instead of looking at what this is, we should look at the result of running this. So if we run this, it takes the string and it converts it to uppercase. So strings have got lots of methods attached to them, and most of them are useful. Okay, so the reason that banana.print doesn't work is that print is not a function that belongs to a string object. Print is a function that runs in the Python space. So anything that you're calling without, it's not associated to the string. So at this stage right now, this is quite a difficult concept to explain. But when we have print over here, it is running as a function in our program. When we're doing something like this, we are taking the string object and looking if it has a print function. So this is applying some operation to a string, and a string cannot be in charge of printing its own information. So if we tried running this, we get another error. And This is an attribute error, which is very similar to our type error that we had. And this is just saying that the string object does not have an attribute print. So there isn't a method called print that a string has. So some other some other examples that we can run are listed here. So the first is .upper. What this will do is it will convert the string to uppercase. We then have .isUpper. So Python does this a lot. If something, it's a check to see something. So we're seeing, is this uppercase? So because it's asking a question, this is either going to be true or false. So in this case, this is all lowercase. So isUpper will return false. In this case, it's all uppercase. So isUpper will return true. Something else we can do is isDigit. And just I get confused. There are lots of different, there's isAlpha, isDigit, I can't even remember all of them. And I always have to go read up on exactly which is the one I want to use for the case that I'm trying to do. So in this case, we have a string 124, and we're checking whether it is a digit. So this is going to return true or false. And this last example will swap the cases around. So B is uppercase, everything else is lowercase. What this will do is make B lowercase and everything else uppercase. So .upper converted our string to uppercase. IsUpper for this lowercase string return false because it's not uppercase. IsUpper for this uppercase string return true because it is uppercase. 124 isDigit tells us to return true because this is a digit. And banana.swapCase, it swapped the cases around. Oh, okay. So that is a good question. When you are running things in Jupyter, what it does is the output of the last thing that you did will get printed by default. So if we have 5 and then print 6, it will only print 6. It won't output the 5. In the same case as if we had 5 and 6, it'll print the 6 because that's the last variable that's represented. So generally, it's better practice to always use prints when you want to print stuff. Don't use this built-in functionality that will output this. Though when we start working in pandas, Jupyter's got some nice things built in that if a data frame is your last object, it will format it nicely for you. Let me just see the question. So because 124 is in string. Oh, yeah. So isDigit is a function for strings. So it can only be applied to a string, and it's looking at the content of the string. So it's going, this string is made up of 124, therefore it is a digit. If on the other hand, we had something like abc.isDigit, that's going to return false because the value of that string is not a digit. Okay, so something else, if you're just working in regular Jupyter notebooks, this is more useful than if you're working in the VS Code version. So if we type help with a string method, or any method for that matter, just note we are looking at what this method is from what I explained earlier, not the result, so there are no parentheses. And if we run this, this will then return the help for the method that we're doing. So in this case, we're looking at the upper method, and this tells us that upper is a built-in function, so it comes standard with Python. Upper with parentheses is a method of the built-in string type, so it's just saying this is a method that belongs to string. And here's an example usage. So if we take a string and we go .upper with parentheses, the arrow tells us what the return is going to be. So this says that running this method will return a string, and then this gives us a definition. So this will return a copy of the string converted to uppercase. So that's very useful. Something else though is when you are writing things in VS Code, it should give you a definition of these while you're typing it. So if we go asd.upper, this should give us help for that. So it's not giving us all the text help, which is a bit unfortunate. I think there might be a way to get that. I'm not sure offhand, but it is telling us what the return type of this is. So it's saying the upper method will return a string. I'll get into that later on. I don't want to waste too much time trying to figure this out. Yeah, no, that's not giving me the help. Yeah, that's also a good point. You can, instead of typing help, you can just use a question mark. I didn't actually know this because this is an R thing, if I'm not mistaken. Okay, so do you have to have the brackets to do that? So I know in R you can do this with the question mark. I don't know about Jupyter. Doesn't seem to work for me. Maybe I'm not doing it correctly. Okay, so that's basically methods for strings. We will use a lot of these as we're going, and we'll go through a lot of them as we're going on as well. So the next thing we're going to look at is different types of objects, such as int strings and booleans, have different methods. So the way you can get a list of these methods, so in VS Code, it was easy. We could just put a dot and it's going to give us a list. If we didn't have this option though, what we can do is use the dir function with a type or variable, and this will return a list of all the methods that can be applied to it. So in this example, we had an integer in the brackets, and these are all the dunder methods that you can just ignore because they are used in the background. You don't need to worry about them. And these methods here at the bottom are the ones that you can apply. So the first is bit length. So we spoke briefly about bits earlier on. So this is how many bits are needed to make up that number. The conjugate, I think, is for complex numbers or something like that. I do not use most of these. Yes, the conjugate and imag and real are for complex numbers. 2 bytes will return it to bytes. In general, with integers, I've never really used any of these methods. It's a bit more useful if we put a string in here, because these methods I've used far more often. So these, we've looked at some of them, like capital, we've looked at is upper, we've looked at upper, and then some other useful ones is split. So what split will do is split a string into small sections. Find will find the first occurrence of something in a string. Center will center justify your string. So you tell it that you want your string to have 3 characters on either side, and it will sort it out that it's always centered. So in general, go through these. You will use a lot of them a lot of the time. Yes, so conversions are quite important. We can look at that now. So if I have a string such as 124 and I want that to be an integer, we can just tell it to cast it to an integer. I think I do cover this a bit later on, but for now, this is just an example. So this is going to take the string and then use integer and the function associated with integer to then cast it to an integer type. So if we type of that integer, it's going to tell us now that this string has been converted to an int. Something that can happen though is if we have something that this is not an integer because it has a character in it, we are then going to get a value error. So this is just, once again, different type of error. It's saying that an invalid literal for int. So int can only type things of base, be cast on things of base 10. And the reason it's saying that is because A could represent a hexadecimal value, and it's telling us that we can only work in base 10. Right, so the next thing we're going to look at are variables. So up until now, every single thing we've done has just been a statement. So we have said 1 plus 5. So that is just performing this expression, and we are not doing anything with the results of that expression. So the next thing that we can do is work with variables. So print and type are both functions, but they serve different purposes. So print will output stuff to the terminal. Type, on the other hand, will return the type of whatever's in the parentheses. So type of 4 will tell us that this is a string because that's a string that's in the brackets. Okay, so using question mark can be done. Yeah, try that out if you want to. The next thing we're going to look at are variables, and variables are ways of storing results over time. So previously when we said 1 plus 5, this is printed and we never ever saving the result of this operation. So it's performing it, but it's not doing anything with the result. Variables offer us a way to store results. So in the most basic case, we can store a value in a variable. And what variables are is on the left of the parenthesis is the name you're assigning to a variable. And on the right is the value that's getting assigned to that variable. Okay, so the reason that you can't get anything from 1 to 4.int is because strings, this is like a separation of concerns. Not all strings are going to be int, so they won't have a built-in method to convert it to an integer. Whereas this way around, we are saying that this string is an integer, so change the type of it from being a string into an integer. So generally, this is just something that was decided by whoever made the language. And they decided that you shouldn't be able to cast by doing things like this. So if we try running this, it's going to give us this attribute error because there is no integer method for strings. So we can't do it that way around. Okay, so getting back onto our variables. In these three cases, we are saving different values in two different variables. So in this case, we are defining a variable called int1. This is up to you. You can call this whatever you like. So always try and keep it descriptive. This is just for this purpose of this class. We are storing an integer. So the first integer in int1, which is 5. We are storing the second integer in int2, which is 10. And then we are adding the two integers together and saving the result in this result variable. So if we run this block of code, we are printing result. So we're printing this variable, and this variable consists of int1 plus int2, so 5 plus 10. The way Jupyter works is it keeps track of all your variables. So if we go in another block now and print result, it will still print 15 because it keeps track of all the changes that have been made. Something else we could do is we could say result is equal to 25 now. So if we run this and we run the next block, it's now going to update to whatever the last value was assigned. There is not a way to see all the variables. I think that in one of the new versions, they're adding that, if I'm not mistaken. I think I saw something about that. When you're working in standard Python, not Jupyter notebooks, you can get a list of all the variables that are active. But yeah, I'm fairly sure that I saw something that they were adding that either to Jupyter Lab, which is a more advanced version of Jupyter Notebook. All right, there we go. Okay, nice. Thanks, David. Okay, so something to be aware of when you are doing these assignments, they happen from right to left. So everything to the right of the equal sign is first calculated. Once the result is calculated, it is then assigned to whatever variable you have on the left. So in both these cases, it will first add these two numbers together to get 6, and then take 6 and store it in the number. It's not saving the expression, it's saving the result of the expression. And in this case, if we had to go banana.upper, it is first calculating the uppercase and then saving the result of that into the variable. I'm not doing anything with these, so we can print number and we can print fruit. Okay, so it's doing those things. And then you can update values. So the way you can update values is by having the current value represented on the right. So this is why expressions are evaluated from right to left, or one of the reasons why at least. So if we just look at these two lines over here, the first thing we're doing is we are assigning 0 to result. So now result represents 0. We are then updating the value of result with whatever result is at this point in time plus 5. So this will get evaluated. 0 will get it replaced over here. So it'll be 0 plus 5. And then that result 5 will then be assigned to result, and it will overwrite the 0 value. So let's make some small changes to this so we can see this actually happening. So let's do this twice rather than once. So we are first assigning 0 to result. We are then saying result is equal to result plus 5. So over here, result is 0. It will get inserted over here. 0 plus 5 is 5. Result will be updated to be 5. This is going to print result, which is 5. We are then going to evaluate this expression, or Python will evaluate this expression, and it will be result plus 5. So now result is 5. It'll be 5 plus 5 is 10. It'll reassign that to result. When we print it over here, it'll be 10. We then assign result to 2, and when we print result, it'll be 2. So the first time it is 5, it is then 10, because 5 plus 5 is 10, and it is then 2, because we're just setting it to be the value 2. So some notes on your variable names is there are some rules that you should follow when you're doing this. So just a lowercase word is fine. A word starting with the uppercase is also fine. And a word starting with an underscore is fine. So all of these are valid variable names, though they all have got different meanings if you look at PEP guidelines. Generally, you want lowercase to be your variable names. So something that you can't have is you cannot start a variable name with the number, and you cannot start a variable name with the special character. So in this case, if we try running these, you'll see already that VS Code has given us some warnings that both of these are invalid. If we try running these, we're going to get syntax errors. So what a syntax error is it means that Python cannot understand what we've actually written, so it can't give us any more meaning. And the reason this is a syntax error is we have got two values separated by a space on the left and one value on the right, and Python doesn't understand how to treat that. So if you wanted to have a variable called number1, you join that with an underscore, and that will then work. When we try run this now, we shouldn't get a syntax error anymore. We'll now get some other type of error. So we still got a syntax error because one with the number, once again, variable names can't start with a number. So Python doesn't know how to understand this. So if we do that, this works. The exclamation mark must have, oh, so the reason that this ran is that exclamation marks are used for running bash commands from Jupyter. So if I type ls like that, it's going to list the contents of the directory. So this didn't even evaluate as a Python expression. This evaluates it as a bash expression. And that's just the nuance of working with Jupyter. So generally, there are a bunch of different naming standards. So some that you would want to follow is a single case lowercase single lowercase letter or a single uppercase letter. Some linters will get angry with you if you do this because you're not giving detailed names. Some other types you can have is lowercase. So this is your general variable, will be all lowercase. Python does not have anything like constants. So the form, the guide people follow is that all uppercase variable names represent constants that shouldn't be changed. The standard way for giving more detail to your variable names in Python is everything lowercase with underscores, or everything uppercase with underscores if you are doing constants. Camelcase is another type of naming which uses capitalized first characters in words. This is used in other programming languages. It's not used in Python very much. Then there's mixed case, where the first word always starts with the lowercase, so everything subsequently will be uppercase. And then there's capitalized words with underscore. I haven't seen this before, though I think it is used in some places. So just in general, when you're coding, some things to be aware of is that a capital I in some fonts and a lowercase l look exactly the same. That is not the case with this font that I'm using at the moment. And number 1 will also look like those in certain fonts. The other thing is that zeros sometimes look like capital O's. Some fonts will either add a dot to the middle of an O or a slash. So generally, it's not a good idea to use capital I as a variable name, as people won't know which of these you're dealing with, and the same thing with O. And this is then just a reference to the PEP 8 style guide. So I've hinted at PEP 8 a few times. PEP 8 is just people sat down and decided what good rules would be for coding to try and get everyone's code to be standardized and looking the same. So if you use Pylint, so when you open VS Code, it asks if you'd like to install Pylint. If you say yes, when you write regular Python files, not notebooks, it will then give you, it'll enforce these guidelines and it'll give you warnings if you're not doing things according to them. Then there are a bunch of reserved words. So these are words that are used by Python, and you cannot use these as variable names. I actually think I might be missing 1 or 2, but this is mostly all of them. So as an example, if we take lambda, which is a reserved word, and we try and assign a variable to that, we are going to get a syntax error. Because lambda is a reserved word, we are not able to overwrite that value, and we cannot use that word as a variable name. If we add an underscore to the front and do it, it's different because this isn't the same as lambda. This is lambda with the underscore, so it's a different variable name. Something else you might run into at some point in time is you can overwrite built-in functions. So built-in functions are not reserved words. So print is a built-in function. And some other examples are sorted, which will sort lists, max, which will return the maximum value in a list, min, the minimum value in print. So in this case, what I'm doing here is I'm printing max, which is the function max. We are then assigning max to 5, and we're printing max again. And you'll see that the first time we print max, it's saying this is the built-in function max. When we have assigned 5 to max, it's now saying that max is the value 5, and we've lost that standard max functionality in our program now. The way that you fix this is by reassigning max to the built-ins object max function. So if we do this and run that, it'll now be back to being the built-in max function. And just as a quick example, what max does is if we have got some numbers, so square brackets denote a list. We'll go more into that later on. So this is the list consisting of 0, 2, and 3, and we would like the maximum value of that list. So this returns 3, which is the maximum value. I'm just seeing we are running out of time. Some of this might have to get moved to the next lecture, but we'll just carry on until we run out of time. So mutability, takes quite a while to get your head around this, but it's not the most complicated topic. This just determines whether you can make changes to a variable or value or not. So some types that you work with are immutable. And what this means is that the original cannot be changed. If you update it, it destroys the original and it creates a new object in its place. Some immutable types are strings, integers, and floats. So what this means is if we update the value in a variable, it will no longer be the same string we're working with. It'll create a new string. On the other hand, some mutable types are lists and dictionaries. These types allow us to make changes to these objects and keep the original object. So this is a fairly high level concept. You don't need to be too worried about this. It's only in certain situations that you'll encounter later on that this might become an issue. So in this case, what we're doing is we're assigning dog to an animal variable, or variable named labeled as animal. We are then printing the ID of this. And what the ID is it is the block in memory that holds this variable. So this is like a street address for the computer to find variables in the RAM. And this is just going to print the ID of that variable and whatever that variable is what that print's doing. We are then adding an A character to the end. So this will then be dog A and assigning that to animal. And when we print the ID of animal, the ID will no longer be the same ID because animal will be a new object in a new place in memory. So this is the address in my memory of where dog was stored. So that is whatever, 5336. When we updated the string to add an A to it, you see that the address has changed. So now animal is pointing to a different block of memory. And if I do this again now and print the ID of animal, you'll see that it's still pointing to that block of memory because it hasn't changed at all. So only when a new string is created does it get put into a new block in memory. So this is an example of immutability. On the other hand, if we take a list, so what this does is we have a list of numbers, 1, 2, and 3. We print the same thing, the block in memory where these numbers are being stored and those numbers. We then add a new number to the end of our list and print the ID again. You see that the ID is the same for both of these because this is mutable. The original can be updated. We don't need to make a new one every time a change is made. The next thing we're looking at is that string methods never change the original. They always will return a new value. So in this first case, we are assigning a string to fruit, which is banana. We are then calling the upper function, but we're not doing anything. So the block in memory is not erased. It's flagged for deletion. So Python keeps track of how many times a variable is being used. And if that number drops to 0, every now and again, Python looks through the memory for all the values that are 0 and frees up that memory. So if you're quick, you could probably recover whatever's in this block of memory and get the same result. But I mean, it'll change by time when you're running the program. So Python's got something called garbage collection. That's exactly what that does. Okay, so in this case, we are running the upper method of the string, but we aren't doing anything with it. It's just like free floating in our code. If we run this, you see banana is still lowercase. So this means that running upper returns a new string. It doesn't change our original string. So if we wanted to get the updated version, we would have to overwrite whatever fruit is with the result of this expression. So this will first convert this to uppercase and then assign the new result to fruit, overwriting the original result. So now we have uppercase banana. This looks like the same thing that I've got for some reason. And variables can also, so this is what I just did up there. Instead of just having a free floating expression, I've assigned the result of expression to a value. What is worth noting with this though, is that if you have a free floating expression in your code, you won't get any errors, nothing will happen. So if we do have this expression running there, we didn't get any errors for running this. This did convert the string to uppercase, we just didn't do anything with the result. So it did happen, it's just nothing's happening with the result of it. All All right, so this was an example of how I will put this into a presentation next week rather. So this is just kind of showing how as values change, the block that's getting pointed to in memory changes. So if we have our empty memory and we assign a variable called foo to variable 1, foo is put into this block in memory. This is not exactly how it works, but you can just think of it like this for the example. And variable 1 points to foo. Then what we do is we say variable 2 is equal to whatever variable 1 is plus bar. So now we have both variable 1 and variable 2. So variable 1 still points to foo. Variable 2 points to foo bar. And then on the other hand, if I say variable 1 is equal to variable 1 plus bar, it now deletes foo from memory and points variable 1 to a new variable called foo bar. And this is something that you need to remember. It won't point variable 1 to the existing foo bar. It will actually create a new foo bar containing variable 1. And I think that's a good place to stop for now. So we'll start the next lecture with compound statements. Compound statements are just operators for logical types. So comparing true and false. So what are the different ways you can do that? And yeah, we'll do that next time. The other thing is getting user input. This is useful, but we will do that next time. All right, any questions quickly?